All right, next up, let's look at indeterminate products, 0 times infinity. So the reason these are indeterminate is because when we have 0 times infinity, um, what's happening is the thing that's going to 0 is trying to make the product 0. The thing that's infinity is trying to make it infinite. And so there's a fight there between those two things to determine what the actual limit's going to be. In this first example we have, let's look at it. Limit as x goes to 0 from the positive side of x times ln x. Now this x is going to 0, but the ln x, if you think about what the ln graph looks like, remember it's got this big asymptote here. So if we travel along the ln graph toward the axis, we're going to negative infinity. So this is 0 times negative infinity. So here's how you deal with these in general. If you've got two things that are multiplied together, a and b, what you want to do is rewrite it either as a over 1 over b or b over 1 over a. In other words, instead of multiplying, like for this first one here, instead of taking a and multiplying by b, you take a and divide by the reciprocal of b. So that will turn this into one of the forms that we've seen before. So for this example, I could either rewrite it as limit as x goes to 0 from the plus side. I can rewrite it as keep the x on top and move the ln down here. So x over 1 over ln x. Or I could rewrite it as limit as x goes to 0 from the plus side of ln x over 1 over x. Now either one of these work just fine. This first one turns it into a 0 over 0, and the second one turns it into an infinity over infinity. I guess technically it's a negative infinity over infinity, but that doesn't matter. It's still an infinity over infinity type. The signs don't really matter as far as determining how to deal with it. It might affect the eventual answer, but it won't affect the technique to use. You'd still use L'Hopital's rule. All right, so we can use either one of these. And so which one is better to use? Whichever one's easier. If I look at this one, taking the derivative of x is nothing. Taking the derivative of that's going to be a little bit of a pain because we'd have to use either the quotient rule or the chain rule. Taking the derivative of this is easy. Taking the derivative of that is easy. So I'm going to go with this one just because it's easier. So let's take that. And if we use L'Hopital's rule, let's see the top. Derivative of ln x is 1 over x. And the bottom, the derivative of 1 over x is minus 1 over x squared. You can do that by using the power rule, but you should just memorize it because it comes up all the time. Now, if you look at what we've got now, this is still a x goes to 0. This is an infinity over infinity type. But we don't want to use L'Hopital's rule again because we can simplify this one just with simple algebra. Limit as x goes to 0 from the plus side of 1 over x. And then we're dividing by minus 1 over x squared. So multiply by its reciprocal. And what we're left with is just the limit as x goes to 0 from the plus side of negative x. And that's just 0. And so that's it. Now, if we want to check this, we can do it on Desmos. If I put in the function y equals x, notice when as we approach 0, this approaches 0. If I put in y equals ln x, as we approach 0, this drops to negative infinity. But if I put in x times ln x, it's really sort of figuring out which one of these things wins. And as we approach 0, the y value of this thing approaches 0 as well. Notice it's undefined right there, but that does corroborate our answer of 0.